In this video, we're going to be talking about query execution plans. Before we dive in, there is a legal note that there is some SQL contained in this presentation, and through copying and pasting and things like that, we can't guarantee that it's going to be correct SQL or that it works, so we just have to state that up front. But for execution plans, so an execution plan is kind of like a roadmap that the query optimizer uses in order to work out how to get you the data that you've asked for in your query. Now, the optimizer is always looking for the most optimal route, and that's what you're going to see. And in fact, there's a lot to see and do with execution plans, and this will not be a deep dive into everything that you could use them for. We're just going to survey specific points about the execution plan to demonstrate some basic performance information that you can gain from it. Okay, so let's talk about indexes, scans, and seeks. These are some key words that you'll want to keep in mind as we look at execution plans. So indexes help you find data faster by ordering the data in a certain way. Rock ships with a number of indexes that are already in place. And the way to think of indexes is, let's say you had to find everyone in a phone book with a first name of Ted. Given that the phone book is ordered by last name, which is kind of like an index, it's the way that it's ordered, you'd have to scan through each name in the entire phone book looking for anybody with a first name of Ted. And this isn't very efficient, okay? But we call that a scan. When we're looking for first name, but the data is organized by last name, we're going to have to go through all the last names and find the first names that we're looking for. However, if there were an index on first name, that would mean the phone book can be sorted by first name. Then, if you're looking for people named Ted, you could just cut straight to the T's or to the TE section and find them all pretty quickly. When SQL does this, we call it a seek. Okay, so when the data that you're looking for, first name, matches up with an index, then it can seek to find that data. And that's, again, the equivalent of just cutting to the T's in the phone book to start looking for Teds. So as you can tell, it's preferable to seek for data rather than scan for it. Okay, so bearing that in mind, we're going to change gears here just for a second. And here we're looking at Microsoft SQL Server Management Studio, or SSMS. And in this tool, there are multiple tools, but we're just going to focus on this one. Under the Query menu is going to be two options. You can display the estimated execution plan, or you can include the actual execution plan. And what we're going to be looking at here is just the actual execution plan. You don't really need the estimated, but it'll tell you what it thinks it's going to do. But it's usually the actual execution plan that we're more interested in. But this is where you enable it. And then once you have it enabled, there'll be an execution plan tab where your results would be. So kind of in the middle of this screenshot here, near the top middle, there's a tab for results, and then a tab for messages, and then a new tab for execution plan. Okay, so here we have a very simple basic query where we're saying select count star from person. So we want a count of all the person records in the database. And we can do this because we have a pretty small database. And so when we run that, down below here it gives us the execution plan that the query is going to use. Execution plans are always read from right to left and from top to bottom. This wasn't a very complex query, so we don't have to worry about top to bottom, but they are read from right to left. And if we look at the rightmost item, that's what we're really interested in here. We can see that this is an index scan. This indicates that an index was found and that each row is having to be checked, right? So we got an index, but it's not really helping us. We need to scan through each row. Now, this text here, index scan, non-clustered, this whole area here, it's hard to show in a PowerPoint, but you can hover your mouse over that area, over those words, and it'll show you, it'll pop up a page that kind of looks like this. And if we look closer at it, there's a few interesting things that we want to glean from this. Again, there's a lot more data on here than what we're going to cover in this presentation, but just to highlight a few pieces, up at the top, again, we can see that this is an index scan, so that again tells us that it found an index, but we're still having to go row by row. And you'll also want to pay attention to a few rows down where it says number of rows read and actual number of rows for all executions. And both of those are 63. And what that's really telling us is we looked out at 63 rows and we returned 63 rows. Now 63 happens to be the number of people in this database that we're using. So remember, our query was select count star from person. And so this is telling us when we ran that query, we read through 63 rows of data and we brought back 63 rows of data, which is what you would expect because we're getting a count star. And then down below, again, there's some other interesting statistics and stuff. But one interesting thing to note is at the very bottom, that object, that's telling us that this came from the person table, so rock.dbo.person. And then the dot after that, the ix underscore title value ID, that's actually the index that the system found that it used to run this query. Okay, so keep that in mind. As here we look at a slightly different example. So here we're doing, instead of count star, we're doing select top 10 star from person. Okay, so that should be a familiar query. That's our default query there in the Power Tools. And so again, we're going to read this from right to left, and you can even see that that middle object there says top, and so you can tell that's right where it calculated, okay, I'm just getting the top 10 rows, so you can see that there. But once again, we're kind of more interested in this very first part here. This is where a lot of the work is done. This is also an index scan. This is using the primary key index, which means that it's sorted on the ID field, because the ID is the primary key. Okay, so if we look at the details for this action, again, we can see that it's an index scan. It wasn't too bad because only 10 rows were read and only 10 rows were returned, so it wasn't reading through a bunch of rows that it didn't need. It got the 10 that it needed and it stopped, and so that's pretty good. And then again, as we go down towards the bottom, we can see the object again, so we know that it was the person object, and then that PK after person, so it says rock.dbo.person.pk underscore dbo. That PK, that's primary key, that's telling us that that's the index that it's using, is the primary key index, which is the ID, so it's sorted by person ID. And then it gives you an output list, and that's really just the names of the columns, the names of the fields that it's going to output. And since we did top 10 star, those are going to be all the fields on the person table. Okay, so let's take a slightly different example, and we're going to select star from the person table where the ID equals 4. So we're looking for all the people, there should only be one, but all the people whose ID number is 4. Okay, and here's our execution plan for that. It looks very similar to the other ones that we've seen. And once again, we're kind of interested in this first part here and looking at what it's doing. So if we dive into that, we can see that now we're doing a clustered index seek. So this is a seek now. And then we can see only one row has been read and only one row has been returned. So that's good. It didn't have to do a bunch of extra work going through all the rows in the database trying to find the person with the ID equal to 4. And if we come down here, you can see under the object that it's rock.dbo.person.pk underscore dbo. Again, that means that it found the primary key index sorted by ID. And since it's sorted by ID, and since we were looking for people who have an ID equal to 4, we were able to seek this time directly to the number that we wanted. And again, we have our output list. So again, that's all the fields that we're bringing back. And since it was a select star, those are all the fields on the person table. And then we have our seek predicates. And that's a really long way to say that it's looking at the person ID field. And so if we were to run a slightly different query, we want just the ID and the first name from the person table, where the first name is equal to Noah. Okay, now we're searching for first names equal to Noah, like the phone book example that we gave at the beginning. Okay, and so if we look at the details for that, we're just going to cut straight here. It's doing an index scan, which means we had to scan, and then if you look, the number of rows read is 63, and the actual number of rows for all executions is 1, which means that we had to scan through all 63 rows. We had to go through every single person in the database to only get one row returned, the one where the first name is equal to Noah. And again, if we go back to our phone book example, that makes sense. You know, names, the person table is organized by last name, so if we were searching for somebody by last name, it might be able to do a seek, but since we're looking at first name and there's no index on first name, it's going to have to do a scan and go through each one at a time. And then again down here we have our predicate, which is the first name, the object, so the index that it found is deceased, last name, first name. And so that's the index that it found. It looks like it's ordered by whether or not the person is deceased, and then by last name, and then by first name. It probably picked that one because it includes first name on some level. And then you have the output list, which this time is much shorter because we just said select ID and first name. So we're only outputting those two fields. Alright, so what we want to do is get this down to reading just one row. You know, it had to go through all 63 rows in the database, every person in our database, in order to get that one row, but we want to get that down. One way to do it, that should definitely not be overused, is to create an index. And it's simple to do, but you don't want to go crazy with it, because there is kind of a law of diminishing returns. And if you want to research more on it, there's lots of articles on the internet about why you shouldn't have too many indexes, but we'll just summarize that here by saying only use this if you really, really need to. If there's a query that's run frequently, that's important to your organization, that's running slowly and doing a bunch of database scans that it doesn't need, only in certain circumstances would you do this. But you can create an index, and the way to do that is you'll write create index, and then you'll give the index a name. So in this case we chose ix underscore first name, and then it's on, and then we have person, that's the person table, and then in parentheses we have first name, and that's what we're going to sort by on the person table. So this is going to create for us an index where the data on the person table is sorted by first name. So you create that index, you get it in there just like that. And now, if we were to check on that index and we do a select top 10 first name and ID from person, we're getting it from the person table. And you can see the index in action here when we select the top 10 from person. You know, you can note that the results are listed in order of first name, and that's our index kicking in. And if we look at the query execution plan for that, well, or for a similar one, let's say that we want to select the first name and the ID from the person table where the first name is equal to Brian. And here's our query execution plan for that, and if we hover over the first part, we'll get our standard list here. But here, with the index in place, it's an index seek, so it did a seek, which is good, that's better than a scan. It read 3 rows where the first name is equal to Brian, and it also returned 3 rows. So again, that's a perfect marriage of your SQL statement, and an index. It's only reading the amount of rows that you're trying to get back, and not extra rows. And then if we continue down, again, we get those same items down at the bottom. We can see the object and the index that was used, which was first name in this case. The output list was ID and first name, and then the seek predicate, which was again first name. And so that's our brief overview of query execution plans. Thanks for watching.